Hello, everyone. My name is Evgeny Zhuk, and here we continue our series about solid principles. So, for people who just joined and its first session, we already talked about first three principles like single responsibility, open closed, and least cost substitution principle. In case you missed it, so you could find it on our YouTube channel. And today we will talk about the fourth one, interface segregation principle. Uh, for me, it's a kind of key principle in all solid, and hope today I will explain why it is. So give me a second. Yeah. I hope you see my screen. So let's jump into it. This, according to the internet, this principle was firstly described and written by Robert Martin. Frankly speaking, I haven't found any proof of this. I haven't found initial article. So in case you exactly know this article or heard about this, please let me know in comment. I will really grateful for this. But anyway, in Robert Martin's books, he's mentioned this principle a lot, and he explained this and describes this as clients should not be forced to depend upon interfaces that they do not use. In other words, keep interfaces small so that users don't end up depending on things they don't need. Everything clear, more or less. And first, when I faced with whole solid conception, and one of my colleagues explained me that simply it's just you should keep your interface small, and small interfaces better than big interfaces. Uh, yeah, frankly speaking, it's almost correct. And here we will discuss why it's partially correct and try to understand it more deeply. Both explanation on the screen, you see it's Robert Martin's quotes, so we will based on this. And since we started with Robert Martin, let's continue with his explanation. And in his clear architecture book, he explained this principle like this. So let's imagine that we have three different classes, like user 1, user 2, and user 3. And all these classes have dependency on ops class. This class has three methods, like operation 1, operation 2, and operation 3. Quite simple. And let's assume that each class use only one method from this ops class. So user 1 use only operation 1, user 2 only operation 2, and user 3 only operation 3. What does it mean? That means that in case we will change something in ops class, during the compilation phase, all these dependent classes will be recompiled. And that's the main concern and the main reason why this principle was introduced. And first of all, it's applicable for compilable languages like Java, C++, C Sharp, and so on. So how it should be fixed to be compatible with interface segregation principle? Pretty easy. The next, we should introduce 3 different interfaces, small interfaces, which interface will reflect one capability of ops class. So it's divided or separated. Operation 1, operation 2, operation 3. In practice, it could be more sophisticated interfaces, but here for illustration, it's only one. And now our user classes are safe. We can change anything in ops class, and during the compilation, user classes or dependent class, any dependent classes will not be recompiled because they don't depend directly from ops class. Here also illustrated dependency inversion principle, which we will talk about next session. And also by introducing these small interfaces, we make it capable with open-close principle as well. So during all my career, I faced many times with this principle, but mostly with languages like PHP or Java. With TypeScript, mostly we used another approach. And let me clarify a little what we meant, what I meant about when I talking about interfaces. In that's screenshot from the Wikipedia, and almost the same explanation I've seen in books about Java, about PHP, about just object-oriented programming, and everywhere interfaces, it's just a scaffold or some capabilities of classes. So in object-oriented programming, interfaces, it's useless without classes. So class should implement some interfaces. And objects, just instance of some classes. That's the key difference, because in TypeScript, interface is shape for object. And in classical OOP languages, interfaces usually contain only methods without properties, but for TypeScript, everything can be in interfaces like methods, properties, optional properties, which is definitely not the case for classical object-oriented languages. So that's why maybe it could be more confused in case you use only TypeScript. So now, assuming that we will use interfaces only as a scaffold for classes, let's probably illustrate this OOP principle in different way. That's the diagram from one of my previous projects. It's simplified, and initially it was on PHP. Now I adopted it a little bit for TypeScript. So the idea that somewhere in the system we have class like product collection. It's simple class, not really simple, but here it will be again simplified. So the main idea behind of this, we having some collection of products which should be iterated in different parts of system. Also, it should be capable with data storage system like ORM, and for be capable with monitoring system, it should be loggable. So Here you can see that product collection implements a few interfaces. So again, in object-oriented programming languages, it's quite a usual thing when one class implements more than one interface. I would say that it's even rare cases when class implements only one interface. Most likely, it will implement many interfaces, like 2, 3, or 4. So here we divided all capabilities of product collection into 3 interfaces. So entity contain everything related to data storage capabilities like ID or other metadata, like when this entity was created, who created this, when it was updated, and so on. Iterable interface. Frankly speaking, it's already implemented in JavaScript and in TypeScript. So it could be in TypeScript, it can be implemented by just adding to the class symbol iterator. And loggable interface, we assume that this class should know how to log himself. Let's illustrate how it should look in code. Pretty simple, just one interface with ID and metadata, another interface product that extends entity, and loggable interface just with one method log. As we talked earlier, that in classical OOP languages, interfaces contain only methods, but for this, interfaces usually created some kind of setters getters. So if it will be in Java or PHP, we will have something like get data method and get metadata, get ID, and so on. For product, get name, set name, and price. So it's good practice in OOP. Do not expose directly object properties, but encapsulated with getters and setters. So here, let's briefly check how it can be implemented in TypeScript, or just simple iterator, constructor with all necessary data. Since we can change ID and some metadata is public, private products with just products array. Here implemented simple iterator, not fully implemented, but just for illustration the idea, and some log capabilities. So log function with some logging logic. And that's some example how it could be in project. Again, in real project, it will be more sophisticated, and we will not iterate just in for. Most likely, it will be consumed by another classes and will be iterated in some subsystems. Again, in logging, most likely we will consume another logger, which will do additional logic and so on. But here, now you could see that each of these parts use different interfaces. To check how it can be in a real system, and it's almost the same as we use it in our project. So we have few capabilities in system like logger. it was a special class which consume other entities and just call log function in there. So here you could see that logger interested only in log function. It doesn't matter which will be passed to this class. It could be, I don't know, product collection, simple product, anything, but it should implement interface logger and system will work. The same for data storage system. Here it's represented with ORM service, which also have some methods, but for this service, only one thing important, that past object should implement entity interface. And in this case, ORM knows what to do with this. The same for another capabilities. Here it's like card counter, which just iterate the product and create card entity for end users. Everything protected. So in case we will change some logic inside product collection, it will not affect any of these services because none of them depends directly on product collection, but everything depends on small and particular interfaces. So this schema show us that applying this interface segregation principle, we can implement fully scalable, flexible, and maintainable system. And we could easily combine our classes and objects based on their capabilities. Because in many projects, I saw something like, one big TypeScript object, like, again, it could be product collection with a lot of properties, with a lot of methods, and close to this file, or even in this file, just interface with the same properties and the same methods. It could be maybe useful for React when we use it for properties typing. But for business logic, most likely it will create unnecessary coupling in the system, and system will be less maintainable. So use this interface segregation, and system will be definitely more flexible. And that's how it works in classical object-oriented languages. And it also can be in TypeScript, because in TypeScript we also could use every capabilities of all OOP languages. How it could be in JavaScript? Based on statement that interface segregation principle more important for compilable languages, it's will be correct to say that for JavaScript, interface segregation principle not so important. And in JavaScript, we even don't have such thing like interface. So how we can adopt it in JavaScript? First of all, it still will be beneficial for JavaScript, but only from a clear code perspective. And it could be implemented only on conceptual level. So since we don't have interfaces, frankly speaking, we could create something which will work like interfaces, but it's really, really overhead, and we don't need it in JavaScript. So let's try to implement this principle in pure JavaScript. Again, it will be just conceptual without any interfaces. So let's imagine that in a system we have three different roles like manager, developer, designer, and all of them have different capabilities. So here on the screen you could see that we have three classes with different capabilities. All these capabilities can be described as a separate function and then just combined in classes. And from these classes can be implemented different objects, and yeah, it will work. Code will be clear enough. We also will follow dry principle here because many our in case we will add additional functions like, I don't know, designer plus developer, it could be combined, and we will reuse these parts of code. Okay, and let's move to the last part of our presentation. And I hope people who use React already seen this picture. It's from React site, and when I first saw it, I don't really remember. It was about 7 or 8 years ago. First, my association it's okay. It's interface segregation, and that's frankly speaking that's correct, because in React, in React Thinking article on their site, the main idea is that we should divide fat components to simple, atomic, and independent components. And then these components can be reassembled to different things. The same that's true for interface segregation. Interface segregation force us to divide fat interfaces to smaller ones, identify unique and common capabilities for the system, implement interfaces, and then combine these interfaces in particular object, particular classes. Absolutely the same idea behind the React, but on components level. So component should be divided into different subcomponents with their own logic, with their own dependencies, and so on. Just to illustrate how it could be in code, let's imagine that we have this user page, which consists of some kind of user profile, user form, and some kind of user activities logs. It's everything combined in one page, in one component, but has three different capabilities. These capabilities separated into different components with their own dependencies. For example, user profile depends only on user, form also depends on user, but also on some additional functionality on save, and user activities doesn't depend on user object, but just from activities. And here just dummy implementation of this approach, some simple user component, profile component, form component, and user activities component, like just a list with some activities. I believe every React users have seen and faced with this situation many times during the career and daily practice. That's it from my side for today. Let's summarize. So, following interface segregation principle help us to make code more maintainable, more flexible, more extendable. And mostly this principle contribute to strong for languages with strong typization, with strong OOP paradigm like Java, C++, C Sharp, PHP, and so on. But since TypeScript also compilable language, also use all paradigm from OOP, it's also applicable for TypeScript and should be used in TypeScript. For languages with dynamic typization like JavaScript, Python, it's less important, but still in these languages we could use benefits from clear code perspective, like again maintainability, flexibility, and so on. That's it from my side. Thank you for joining. About the questions, sorry, I forgot to mention it at the very beginning. So we will have a separate session because I can't just check your comments during the translation, during the broadcasting. So all comments, all questions will be processed, and we will have a dedicated event, and I will answer all questions for all topics, not only for this one, but for previous and for next our topic, which will be, I hope, in 2 or 3 weeks, and it will be for dependency inversion. Thank you. That's it. Have a good weekend. Bye.